Today we'll be doing the prefixes. Now, what are the prefixes? Actually, prefixes are the powers of the 10 which have some fixed symbols in physics. For example, when you write 5 into 10 power 3 gram, it is just 5 kg. Or suppose 50 into 10 power 3 meters, just 50 kilometer. So this kilo is the prefix for the 10 power 3. Now there are some prefixes with the exponent of positive exponent and some are with the negative exponent. Let's discuss all those. Here is the prefix, this is the exponent form of the prefix, exponent form, and here is the name of the prefix. Name of the prefix, then its symbol or its abbreviation. So first is, I'm just writing first the minus exponents. The 10 power minus 1 is for deci, small d. 10 power minus 2 is for centi, small c. 10 power minus 3 is for milli, small m. 10 power minus 6 is for micro, it is read as mu. Then read as mu. Then its 10 power minus 9 is nano, it's small n. Then 10 power minus 12, 10 power minus 12 is pico, small p. Then it is 10 power minus 15 is femto, small f. Then 10 power minus 18 is ato, small a, or lowercase a. So these are in lowercase. 10 power minus 1 is deci, 10 power minus 2 is centi, 10 power minus 3 is milli, 10 power minus 6 is micro, this is read as mu, is a Greek letter. Then 10 power minus 9 is nano, small n. 10 power minus 12 is pico, 10 power minus 15 is femto, then 10 power minus 18 is ato. Now these prefixes will be with the positive exponent same, only I'm just deleting here the minus sign, but the names will be different now, of course. The names for 10 power 1 will be not deci. Let us first, I'm just deleting all those. So these prefixes play a very vital role in multiplying and other things in physics notation. So many things, these are very helpful. 10 power 1, now I'm choosing the positive exponents. 10 power 1 is for deca, dA. It is only the prefixes having 2 letters in the symbols. Then 10 power 2 is hecto, small h. 10 power 3 is, this 10 power 3 is kilo, small k. 10 power 6 is mega, capital M. 10 power 9 is giga, capital G. 10 power 12 is tera, capital T. 10 power 15 is peta, capital P. 10 power 18 is exa, capital E. So these are the symbols you must remember. 10 power 1 is deca, but 10 power minus 1 is deci. 10 power 2 is hecto, but 10 power minus 2 is centi. 10 power 3 is kilo, but 10 power minus 3 is milli. 10 power 6 is mega, but 10 power minus 6 is micro. 10 power 9 is giga, but 10 power minus 9 is nano. 10 power 12 is tera, but 10 power minus 12 is pico. 10 power 15 is peta, but 10 power minus 15 is femto. 10 power 18 is exa, but 10 power minus 18 is ato. So these are the prefixes. Now there are some rules for the prefixes which you should know, and there are 3 rules. These are the rules for the prefixes. Rules for prefixes. What are those rules? Rule number 1 states, okay, actually there must not be a space or a multiplying sign between a unit and a prefix which always comes before the unit. So there must not be a gap. For example, if you want to write 50 millisecond, you write 50 millisecond, this is correct way. But if you write in this way, I'm sorry, this will be wrong. This can be treated as 50 meter into second. Okay, for example, if you have 500 millinewton, this is correct. But if you write 500 this is for meter. If you give a space, this become a unit, not a one, or you can, this is 500 meter newton, or it is equal to 500 newton into meter. So take these prefixes, these are not the prefixes, these are just meter, this is the prefix. So prefix must not have a space, there must not have a space between the unit and a prefix, rule number 1. Rule number 2 states, no two prefixes can be used together. No two prefixes can be used together. For example, you cannot write 50 mega kg, but you should write 50 into 10 power 6 kg. You cannot write 600 nanocentimeter, that's wrong. You can write 600 into 10 power minus 9 centimeters or 600 into 10 power minus 2 nanometers. Both are correct, but there must not be two prefixes together. Rule number 3 is very important. It states that pu whole power n is it is actually, it's pu power n, it means it's pu whole power n, means when the power is on the unit, it is still to be understood, it's on the prefix also. For example, it's a very useful rule for changing the suppose other things into proper SI units. For example, suppose 50 centimeter square, then it is 50. Now square is on meter, but it should also be, it is on centi. So 50 centimeter whole square, or is 50 into 10 power minus 2 meter whole square, or is 50 into 10 power minus 4 meter square. Or suppose it was 50 centimeter cube, it's just 50 centimeter whole cube, or is 50 10 power minus 2 meter whole cube, or is 50 into 10 power minus 6 meter cube. Here an important thing, here 10 power minus 6 is a prefix for which we can use the micro, but we cannot use here a micro. If I use a micro, then this power of 3 will also be on the micro, which will be wrong. So we can, from this rule, we can say if there is power on a unit and the prefixes together, we cannot write that in the prefix form. For example, if it is just 50 into 10 power 3 meter square, you cannot write this as a 50 kilometer square, because if you want to change 50 kilometer square, then 50 kilometer square is this 50 and km square, or it's actually 50 into 10 power 6 meter square, but not this one. So this one, it means given the P is a prefix, use a unit, then pu power n means pu whole power n, whereas P is a prefix and use a unit.